In this video, we're going to review the idea of the limit definition of a derivative. And we know that when you have a derivative of a function, so for example, look at this one. So we have a function. So what we're trying to do is the derivative at a point. So we know that this one you can get as you if you draw the small triangle for a nearby point like that. So what we do is we're going to pick this one as x, and then we're going to pick this gap as h. So this is going to be x plus h. Um, so we can evaluate the function at those 2 points. One is fx, the other point is fx plus h, x plus h. So what we do is we can take the ratio. So this is the f x plus h minus fx, and then divided by the gap of y. So this is the gap of x, which is h. This is the gap of y. This is fx plus h minus fx. So what we do is we divide these two. So that is what we call the different quotient. So we look at the different quotient and then take the limit when h goes to 0. And you can see that when h goes to 0, this secant line, so there's a secant line here. So if you connect these two, there's a secant line. You can see the secant line simply becomes the tangent line when h goes to 0. So that means what to happen is when this limit exists, you're going to get simply the derivative at the point x. So this is what we normally call the limit definition of the derivative. So what you need to do is we need to evaluate the function at x. We need to evaluate the function x plus h, take the difference, divide by h, take the limit. So once you do that, this is what we call the limit definition of the derivative. So this is the limit definition of the derivative. Limit definition of the derivative. So let's use this idea to find derivatives of maybe like two functions. So let's look at the first one. So we have the problem, use the limit definition of the derivative, use the limit definition of the derivative, use the limit definition to find the derivative of this function. So if you get a problem like that, the first thing that we do is we're going to rewrite this one as fx. So we say, we can say let. So let fx equal the function which is 3x over 5x minus 2, and then what we do, we use the limit definition. So we can we write it, so we know that the f prime x equals to, by the definition, it's always a good idea to write this when h goes to 0, f x plus h minus fx divided by h. So let's plug in. So which is limit h goes to 0. So you're going to plug in x plus h wherever you see x. So it is 3 x plus h divided by 5 x plus h minus 2, and then minus fx is the function itself, 5x minus 2, divide the whole thing divided by h. So that's what we have. Now we're going to simplify. So we plug in here. So that part is done. Next is just the algebra part. So let's do that. So how we do it? So you can see, first one thing we can do is we can see this common factor. We can take it out because we can make it as simple as possible. So we take it out. That's the first thing we can do. And the limit. So we have h goes to 0. You can see you have to divide by h. So division by h you can write as multiplication by 1 over h. So we can write it like that. So also make the algebra easy. And then next we use the so-called 3-arrow argument here because it's like algebra simplification. So we use the 3a argument, If you don't know that, you can search that in my channel and you can find the three, what is the three argument is. So we do that. So when you do that, and you can see simplifies really well. So you're going to multiply the first arrow, so which is x plus h times 5x minus 2. That's the first arrow. Minus the second arrow is x times the whole expression. So if you expand it, you get 5x plus 5h minus 2. That's the second one, second arrow. The third arrow is everything in the bottom you multiply as a just multiply it. So you can write it if 5x plus 5h minus 2. That's the first one. You don't have to, but you can write it like that, and then 5x minus 2. So that's what happened. Now rest is just the algebra part. So what do you do? Just simplify the top, just multiply through these two, and you can see that so many terms get cancelled, and then divide by h and simplify. So let's do that next. So we get this one is equals to, so it is f prime x equals to, we have 3, and also we have the limit when h goes to 0. So let's write the expression now. So if you distribute, what you get is 5x squared minus 2x plus 5 times xh and then minus 2h. That's what you get in the first one. From the second one, you're going to get 5x squared minus 5xh and then plus 2x, and then divided by the product. So we leave the product as it is. We don't distribute this. We just leave it like that. You will see the benefit later in the last step. And this one is 5x minus 2. And you can see that there are so many terms get cancelled. For example, 5x squared get 5x squared get cancelled out. And then also negative 2x and 2x get cancelled out. We also have 5xh and negative 5xh get cancelled out. So only thing that you left with is negative 2h, and then we also forgot the h term. Remember 1 over h term? So you can write it here, 1 over h. Now what you can see is, so in the next step, after that, after we cancel these, you can see you can cancel the h term. So what we have is 3 limit, I just exaggeration here because you can cancel over there. So it's 1 over h term times what we have is negative 2h over the product of these two terms, 5x plus 5h minus 2, and then 5x minus 2. That's what we have. And then you can see you can cancel the h term now. So once we cancel the h term, and then you can take the limit when h goes to 0. So you can see that when that happen, when h goes to 0, you can see this term goes to 0. So you simply get negative 6 over the square of the bottom term. So it's 5x minus 2 whole thing squared as the final answer for this one. So you can see it's not that difficult, but there are some algebra that you need to do. Okay, so let's look at the next problem. As the next one, let's look at this one. We have y equal 5 times square root 2t plus 7. So we again use the same argument. So first thing is we can rewrite this one as ft equal 5 2t plus 7 square root, and then the limit definition is, now we have the t. So if prime t equal, we have limit when h goes to 0 f t plus h minus ft divided by h. So that's the limit definition. So let's plug in here. So we have limit h goes to 0. So if you plug in, so you want to replace every t by t plus h. That's what you want to do. So let's do that. So it is 5 square root. So every 2 you replace by t plus h. So it's t plus h here. And then plus 7, no change, minus, here there are no changes. So it is 2t plus 7 divided by h. So we substitute. So the substitution is correct here. That's substitution. So you have the right equation and substitution. After that, we just need to do the algebra part. So there are a few things again we can do. You can see this 5 is common, so you can pull it out. It's going to make it simple. It'll be simple. So let's do that. So I'm going to start here because there are a lot of writing. So it's 5 out. We have limit h goes to 0. So let's write what we have here. So we have 2 t plus h plus 7 square root minus 2t plus 7 square root divided by h. So from algebra, we know that when you have square root functions, the trick is to multiply by the conjugate, multiply by its conjugate. When you do the conjugate, we only change the sign in between here, not anywhere else. So we're going to multiply the top and bottom by the conjugate of this. So that means the one with the opposite sign. So that means you're going to get 2 times t plus h plus 7, no change, square root, plus, instead of minus, you put a plus sign, and then 2t plus 7 square root. And you do the top and bottom because it's like multiplying by 1. That's why we can do this without changing any other terms, because you are simply multiplying by 1. Plus, it's the same term. When you write the same term, top and bottom, it is 1. Okay, now we have this. And then what we can do, we're going to multiply the top two terms. Remember the algebra. So when you multiply a minus b with a plus b, what will happen? This is what we normally call the difference of squares identity. You get the square of the first term minus the square of the second term. So that's what happened. This is one of the identities that we use a lot in calculus. Difference of squares identity. So because of that, you can see that's exactly what happened here. You can see the first term is like a minus b, second one is like a plus b. So that's the situation. So because of that, you square the first one. When you square the first one, the square root term going to cancel out. So that means this is going to be simply 5 limit h goes to 0. Once you cancel out the square root, you get 2 t plus h plus 7 minus the other term, which is 2t plus 7. Again, the square root get cancelled out. Divided by, you have the h, you can write it like that. And then we have the term coming from the other term. So which is 2t plus h plus 7 square root plus the other term, which is 2t plus 7 square root. And then you can see there are a lot of terms get cancelled out. For example, 2t cancel out the 2t, we just cancel t, that means whole term get cancelled out. And the 7 get cancelled out 7. When I cancel, I normally cancel with different angles, then we know like what to do. This is kind of good practice. So only thing that we left with is 2h. So now we have the h, so we're going to cancel the h term, and then we cancel the h term, and then, so let's cancel this term now. We can cancel it before, but now we can cancel. And then send the limit h to 0. So that means this term going to go away. So that means you simply the bottom gets doubled. So that means there's a 2, and then that 2 cancel with this 2. So that means you finally get the final answer as 5 over, that's the only term left with in the top. And then you get the bottom term going to be 2t plus 7 square root, because the 2 get cancelled out. So that's the final answer for this problem. That's how we do it. So it's not that difficult, but there's a special way to do it. Okay, so it won't take that much time when you do it, because I'm explaining this, and that's why it can take time. But you can just do a problem like that in like less than 5 minutes. Okay, thank you so much.